Harley-Davidson promised power. They delivered a problem. The Milwaukee-Eight 117, Harley's biggest, baddest V-twin production engine, was supposed to be the answer to every rider's dream. More cubic inches, more torque, more American muscle wrapped in chrome and legend. But there's something they didn't tell you in the showroom, something the dealerships won't mention until you're 3,000 miles down the road with an oil light flickering and your hand reaching for yet another quart of synthetic. Bigger doesn't always mean better. And in 2026, owners are discovering the dark side of displacement the hard way. Oil consumption, engine sumping, power loss, breakdowns on the highway, heat so intense it feels like your legs are being roasted on a grill, random throttle cuts that leave you coasting helplessly through traffic. This isn't just about a few bad units or isolated cases of manufacturing defects. This is a pattern that goes back to 2017 when the Milwaukee-Eight platform first rolled out, and it's getting worse with every cubic inch Harley adds to the equation. The 117 isn't just a slightly enlarged version of the 114. It's a magnification of every flaw, every shortcut, every compromise that Harley made when they designed the Milwaukee-Eight family. And now, riders who drop $25,000, $30,000, even $40,000 on their dream touring bike are living a nightmare of constant oil checks, mysterious power losses, and dealerships that shrug and say it's all within spec. If you want more insane stories like this, hit like and subscribe, because what you're about to hear might save you from the most expensive mistake of your riding life. We're going deep into the engineering failures, the real-world disasters, the financial devastation, and the complete breakdown of trust between Harley-Davidson and the riders who built this company with their loyalty and their wallets. The Milwaukee-Eight 117 was introduced in 2018 as Harley-Davidson's performance answer to riders demanding more grunt without going full custom or dropping insane money on a Screamin' Eagle build. It replaced options on the aging twin-cam platform with modern design, liquid cooling on some models, 4 valves per cylinder, and a single cam setup that promised smoother power delivery and better efficiency. The 117 cubic inch engine, that's 123 cubic centimeters for those keeping track in metric, produces around 105 to 114 horsepower depending on the year and model, with torque figures ranging from 124 to 130 pound-feet. The newer 2025 models with the high output tune are pushing 128 pound-feet of torque and 114 horsepower, which represents an 11% increase in peak horsepower over the standard 2024 117 configuration. It debuted in CVO models like the Road Glide, Street Glide, limited editions, and eventually found its way into the Fat Boy, Lowrider S, and Lowrider ST. Harley marketed it as the ultimate cruiser power plant, blending classic V-twin soul with 21st century engineering. The bore measures 4.075 inches with a stroke of 4.5 inches, giving it that long stroke torque character that Harley riders love. At just over 2,400 RPM, the 117 is already pumping out 90 pound-feet of torque. By 2,700 RPM, it hits the 100 pound-foot plateau and stays there until nearly 5,000 RPM. The horsepower curve is remarkably linear, climbing smoothly to its peak around 4,350 RPM and staying above 90 horsepower from 4,600 all the way to 5,750 RPM before hitting the red line around 5,900 RPM. On paper, it's a beast. The marketing materials show stunning chrome-covered engines, riders cruising through scenic landscapes, freedom and adventure personified in metal and leather. In the real world, it's a different story entirely. But here's the catch that Harley never put in the brochures, the fine print that doesn't exist, the conversation that never happens during the test ride. Bigger engines generate more heat, more friction, and more stress on internal components. When you scale up displacement without fully addressing fundamental design flaws from earlier Milwaukee-Eight versions, you don't just inherit their problems, you amplify them. You take issues that were manageable on a 107 cubic inch engine and turn them into catastrophic failures on a 117. The 117 shares the same basic architecture as the 107 and 114 models that came before it. Same oil pump design on early models, same crankcase ventilation system, same oil return pathways, same bearing sizes and tolerances, same gasket designs, but now you're asking those components to handle significantly more displacement, more combustion pressure, more heat cycles, and more combustion byproducts. It's like taking a water pump designed for a garden hose and connecting it to a fire hydrant. Sure, it might work for a while, but eventually the system gets overwhelmed. And that's exactly what's happening with the 117. The oil system, which was already marginal on the smaller Milwaukee-Eight engines, is being pushed beyond its design limits on a daily basis. Every time you twist the throttle, every time you cruise at highway speeds in summer heat, every time you load the bike with a passenger and luggage and ask it to climb mountain passes, you're stressing systems that are operating at the ragged edge of their capacity. The result is a cascade of problems that start small and grow into major headaches. A little oil consumption at first, then more. Then sumping that robs power, then overheating that damages gaskets, then leaks that get worse with every heat cycle, then warning lights, then random shutdowns, then catastrophic failures that leave you stranded hundreds of miles from home with a repair bill that rivals the cost of a used car. What comes next is where things get ugly, where the dream of owning Harley's most powerful production V-twin turns into a maintenance nightmare that has owners questioning whether they made the right choice, whether Harley-Davidson still builds reliable motorcycles, and whether this company deserves the legendary status it claims. Owners across forums, Facebook groups, Reddit threads, and even Harley owner meetups are reporting the same terrifying trend with disturbing consistency. Excessive oil consumption. We're not talking about a little bit of oil burning off over 5,000 or 10,000 miles, like you might see on a well-worn engine with 100,000 miles. We're talking a quart or more every 1,000 miles on bikes with less than 5,000 miles on the odometer. Some riders report even worse consumption, watching their oil level drop from full to the add mark in just 500 miles of highway cruising. That's not normal. That's not acceptable. That's not what you expect when you buy a brand new motorcycle from a company that's been building V-twins for over a century. One rider with a 2023 Milwaukee-Eight 117 reported burning oil so fast they had to carry extra bottles in there. Saddlebags on long rides, checking the level every fuel stop like it was a religious ritual. They described the anxiety of watching that dipstick, wondering if this would be the tank of gas where they didn't catch it in time, and the engine seized on the interstate at 75 miles per hour, with semi-trucks bearing down from behind. Another owner watched their oil light flicker on at just 4,200 miles right after their first scheduled service at the dealership. They'd left the shop with a fresh oil change, new filter, everything supposedly perfect, and within 200 miles, the bike was already down a quart. When they went back to the dealer, frustrated and concerned, the service manager pulled up a technical bulletin and pointed to a line that made their blood run cold. Harley's official response, documented in service bulletins and repeated by dealerships across the country, states that 1 quart per 1,000 miles is within normal operating range for the Milwaukee-Eight platform. Read that. Again, slowly. 1 quart every 1,000 miles is considered normal. That's industry speak for, we know there's a problem, but we're not calling it a recall, and we're not extending your warranty to cover the consequences, and if your engine fails, because of it, after the warranty expires, you're on your own. For context that reveals just how absurd this standard is, most modern motorcycle engines consume virtually no oil between service intervals. A well-designed engine might use a few ounces over 5,000 miles, so little that you can't even measure it on the dipstick. Japanese bikes from Honda, Yamaha, Kawasaki, and Suzuki routinely go entire service intervals, sometimes 8,000 or 10,000 miles, without needing a single drop of oil added. Even older Harley engines, the Evolution and early twin-cam models, didn't consume oil at anywhere near this rate unless something was seriously wrong, like worn piston rings or valve guide seals that needed replacement. But with the Milwaukee-Eight 117, consuming a quart every 1,000 miles is the new normal, the acceptable standard, the baseline expectation that Harley has apparently decided is good enough. Do the math on what this means for real-world ownership. If you ride 10,000 miles a year, which is pretty average for someone who actually uses their touring bike for touring, for taking trips and enjoying the freedom that motorcycles are supposed to represent, you're adding 10 quarts of oil between services. That's more than 2 complete oil changes worth of oil just disappearing into the combustion chamber or leaking out through gaskets. At $10 to $15 per quart for quality synthetic oil, which is what these engines require, that's an extra $100 to $150 a year just in oil top-offs. And that's if you're lucky enough to catch it in time every time. If you're on a long ride through an area where motorcycle shops are scarce and you don't notice the oil level dropping, you risk running the engine low on oil. And when a big air-cooled V-twin runs low on oil, bad things happen fast, really fast. Bearings start to suffer from inadequate lubrication. Piston rings lose the oil film that prevents metal-to-metal contact. The cam system, which relies on consistent oil pressure to function properly and maintain hydraulic valve lifter operation, begins to wear at an accelerated rate. Cylinder walls get scored, connecting rod bearings start to knock, and suddenly, you're not just looking at oil consumption as an inconvenience, you're looking at premature engine wear that could lead to catastrophic failure down the road. A failure that will happen at the worst possible time, in the worst possible place, and cost you thousands or even tens of thousands of dollars to repair. The issue stems from poor oil scavenging in the crankcase, a problem that's been documented, discussed, complained about, and argued over since the earliest Milwaukee-Eight engines rolled off the assembly line in 2017. The oil pump, especially in 2017 through 2019 models, simply can't keep up with returning oil from the bottom end of the engine back to the oil tank where it belongs. Oil builds up where it shouldn't, pooling in the crankcase and around the flywheels, and it gets churned by the rotating assembly spinning at thousands of RPM. When the flywheels spin through pooled oil, they turn it into an aerated foam, whipping air into the oil like a kitchen mixer. This aerated oil can't be pumped effectively because the pump is designed to move liquid, not foam. The foam either gets past the piston rings and burns off through the combustion chamber, sending blue smoke out the exhaust pipes that eagle-eyed riders notice but dealerships claim is normal, or it forces its way past gaskets and seals under pressure, creating leaks at the rocker boxes, pushrod tubes, cam cover, and primary cover. With the 117's increased displacement and massive heat output, the problem amplifies exponentially in ways that the engineers either didn't anticipate or chose to ignore in the rush to get the bigger engine to market. More power means more combustion pressure pushing past the rings during the power stroke. More displacement means more oil being splashed around inside the crankcase with every revolution. More heat means thinner oil that's more likely to slip past seals and flow through gaps that would contain thicker, cooler oil. The oil pump that was barely adequate for the 107, marginal for the 114, is completely overwhelmed by the demands of the 117. Harley did release an updated oil pump design after 2020, increasing the scavenge capacity and improving the internal clearances to better handle oil return under high temperature conditions. But reports of excessive oil consumption haven't disappeared. They've decreased in frequency, but they haven't been eliminated. The new pump helps. It definitely helps, but it doesn't eliminate the problem entirely, especially on bikes that see hard use, hot weather riding in places like Arizona or Texas or Florida, or extended highway speeds where engine temperatures climb and stay elevated for hours at a time on cross-country trips. Still with us? Because what comes next will shock you. Oil consumption is just the visible symptom, the thing you can measure on a dipstick and track in a notebook. The underlying disease is something called sumping, and it's the silent killer of Milwaukee-Eight performance, reliability, and owner satisfaction. Sumping, also known as wet sumping in motorcycle and automotive circles, is a condition where oil, instead of returning efficiently to the oil tank where it belongs in Harley's dry sump system, builds up in the crankcase and cam gear case. This creates a pool of oil at the bottom of the engine that shouldn't be there, that the engine wasn't designed to accommodate, that interferes with normal operation in multiple devastating ways. In a properly functioning dry sump oil system like Harley uses, the scavenge side of the oil pump continuously pulls oil out of the crankcase and sends it back to the external oil tank in a cycle that keeps the crankcase relatively dry, hence the name. The pressure side of the pump then sends oil from the tank to the bearings cam and other components that need lubrication. It's a continuous loop that's supposed to keep oil moving, cooling, and lubricating. But when the scavenge pump can't keep up with the volume of oil entering the crankcase, oil accumulates. The result is loss of power, extreme heat generation, and a sluggish, lethargic ride that feels like you're dragging an anchor behind the bike, like the engine is fighting against itself, like something fundamental is wrong, but you can't quite identify what. Riders report significant power loss at highway speeds, the bike feeling flat and unresponsive when you twist the throttle to pass a car or merge into traffic. They report overheating, so severe that the bike becomes uncomfortable to ride, with heat pouring off the engine and cooking the rider's legs even on bikes equipped with liquid-cooled cylinder heads that are supposed to run cooler. There's a general feeling that the engine is choking, struggling, fighting against itself with every revolution, and they're absolutely right. The engine is fighting itself in ways that rob performance and create damage. When oil sumps in the crankcase, several catastrophically bad things happen simultaneously, creating a perfect storm of mechanical stress and premature wear. First, the rotating flywheels and connecting rods have to push through that pooled oil with every rotation. This creates massive parasitic drag, resistance that absorbs energy that should be going to the rear wheel. It's like trying to run through waist-deep water. You're expending all this energy, all this effort, just moving through the medium instead of moving forward. Your legs burn, your lungs heave, but you're barely making progress because the resistance is so high. The same thing happens inside the engine. The flywheels are spinning at thousands of RPM, and every rotation they have to push through oil, wasting horsepower and generating heat from friction. Second, when the flywheels churn through the oil, they aerate it aggressively, whipping it into a foam that has dramatically different properties than liquid oil. This foam takes up significantly more volume than liquid oil because it's mostly air bubbles, which means even more drag and even more resistance to rotation. The aerodynamic drag of moving through foam at high speeds is enormous. Third, and this is critical for long-term engine survival, the aerated oil can't lubricate properly. Oil needs to be liquid to form a protective film on bearing surfaces, to separate metal from metal, to carry away heat and contaminants. Foam doesn't lubricate, it just creates friction and heat. The bearings, the cylinder walls, the piston, rings, all of them start operating with inadequate lubrication, even though the oil tank might show a proper level. The oil is there, but it's in the wrong place and in the wrong form to do its job. Fourth, because the oil is trapped in the crankcase, instead of circulating through the oil cooler and back through the tank where it can shed heat, it gets hotter and hotter with each engine cycle. Hot oil loses viscosity rapidly. It gets thin, runny, like water instead of like honey. Thin, overheated oil provides dramatically less protection to critical engine components. The protective film breaks down. Metal-to-metal contact increases. Wear accelerates. And fifth, because so much oil is trapped in the bottom end, the oil level in the tank drops. The pressure side of the oil pump starts pulling from a depleted supply, potentially cavitating or drawing air into the system, which creates even more problems, including loss of oil pressure warnings, illuminated dash lights that freak out riders, and potential damage to the pressure side of the lubrication system that relies on a constant supply of liquid oil to function. The root cause of sumping is that fundamentally inadequate oil pump design that we discussed earlier, a design that represents either incompetence or willful corner cutting by Harley's engineering team. In Milwaukee-Eight models produced through 2019, the stock oil pump simply couldn't transport excess oil fast enough from the crankcase back to the tank under real-world operating conditions. The pressure side of the pump, which sends oil to the engine components, was adequate for that task. But the scavenge side, which has to pull oil back out of the crankcase against gravity and through restrictive passages, was undersized for the volume of oil and the difficult conditions it needed to handle. Even worse, as sumping progresses and more oil accumulates in the crankcase, the problem becomes self-perpetuating, a vicious cycle that gets worse and worse, until mechanical intervention occurs. More oil in the crankcase means more aeration as the flywheels churn through it. More aeration means the pump has an even harder time scavenging because it's trying to pump foam instead of liquid. More resistance means more heat generation. The oil gets thinner from the heat, and the cycle continues spiraling downward, getting worse with every mile until the rider either shuts the bike down to let it cool and drain, or experiences a significant mechanical failure that requires towing and expensive repairs. Some riders noticed sumping symptoms as early as 5,000 miles on brand new bikes fresh from the showroom. Others got lucky with better assembly tolerances or different riding conditions and didn't see issues until 12,000 or 15,000 miles. But once it starts, it doesn't stop without intervention. The bike doesn't heal itself. The problem only progresses, only gets worse, only creates more damage until someone installs an upgraded oil pump, dramatically changes their maintenance practices and riding style, or in the worst cases, suffers catastrophic engine damage that requires a complete teardown and rebuild at costs that can exceed $10,000. Harley released updated oil pumps starting in the 2020 model year after the complaints reached a level they could no longer ignore, and aftermarket companies like Fueling stepped in with high-flow oil pump designs specifically engineered to address the issue that Harley created. The Fueling oil pumps feature larger scavenge gears with more teeth and better profiles, improved oil pathways with less restriction and better flow characteristics, and tighter internal clearances that improve pumping efficiency. These pumps can move significantly more volume than the stock Harley pump, sometimes 30 to 40% more oil per revolution. Riders who installed these upgraded pumps reported immediate and dramatic improvements. Power came back, often gaining 5 to 10 horsepower at the rear wheel just from eliminating the drag of sumping. Operating temperatures dropped by 20 to 30 degrees because the oil was circulating properly and cooling effectively. The bike felt responsive again, eager, alive the way it should have felt from the factory. But here's the kicker that reveals the true cost of Harley's engineering failures. These pumps cost anywhere from $500 to $800 just for the part, just for the hunk of machined aluminum that should have been installed at the factory. Installation requires splitting the engine cases on some procedures, or at minimum removing the outer primary cover, the cam cover, the cam support plate, and the entire cam drive system to access the oil pump mounting location. This isn't a simple bolt-on job that a shade tree mechanic can do in an afternoon with hand tools. It requires special tools, precise torque specifications, careful attention to cam timing, and knowledge of Harley-specific assembly procedures. Experienced mechanics at competent independent shops can complete the job in 4 to 6 hours if everything goes smoothly. For DIY riders with the right tools, service manual, and knowledge, it's a challenging weekend project that tests skills and patience. But for most owners, people who bought a Harley to ride it, not to wrench on it constantly, it means paying shop labor rates that run $100 to $150 per hour, depending on location and dealer overhead. Do the math. 6 hours at $125 per hour is $750 in labor. Add the $600 pump. Add gaskets, oil, filter, and miscellaneous supplies for another $150. You're looking at $1,500 total to fix a problem that shouldn't exist, that represents a fundamental design failure, that should have been corrected by Harley under warranty or recall, but instead becomes an out-of-pocket expense for owners. And that's just the oil pump upgrade. Many riders also upgrade their gaskets while they have the engine torn apart because it makes sense to replace wear items when you're already in there. The factory rocker box gaskets on Milwaukee-Eight engines are notorious for leaking, especially as the engine racks up miles and experiences repeated heat cycles that cause the gaskets to harden, shrink, and lose their sealing capability. Upgraded gaskets from James Gaskets or Cometic, made from better materials with better designs that handle heat cycling more effectively, provide better sealing and longer life. Add another $200 to $300 for parts and labor if you're doing gasket replacement at the same time as the oil pump upgrade. Some riders go even further, installing auxiliary oil coolers to increase heat rejection or upgrading to larger capacity oil tanks to increase the total volume of oil in the system. More oil means each quart has more time to cool before cycling back through the hot engine, which helps manage temperatures and reduces thermal stress on the oil itself. But these are Band-Aids on a bullet wound, stopgap measures that address symptoms without fixing the underlying disease. The real issue, the fundamental problem that no amount of aftermarket parts can completely solve, is that the 117's core architecture inherits problems from the original Milwaukee-Eight design that was introduced nearly a decade ago. Harley took the 107 platform that had known issues, bored it out and stroked it to create the 114, then pushed it even further to 117, each time adding displacement and stress without a fundamental redesign of the lubrication system, the cooling system, the bearing sizes, the gasket designs, or the internal components to handle the increased demands. It's like building a skyscraper on a foundation designed for a 3-story house. Sure, you can add reinforcements and workarounds and hope it holds together, but eventually the underlying structure can't support what you're asking it to do, and physics doesn't care about marketing promises or brand. Loyalty or a century of history. Physics wins every time, and when it does, the results are catastrophic for the owners who trusted the brand. Other riders, recognizing that Harley isn't going to fix these problems and that aftermarket solutions are expensive, adjust their maintenance routines and riding habits to compensate for the fundamental design flaws. They check oil level religiously before every single ride, even short trips to the store, and at every fuel stop on longer rides. They change oil far more frequently than Harley recommends, running 2,500 or 3,000-mile intervals instead of the factory-recommended 5,000 miles, essentially doubling their oil change frequency and cost. They use only premium synthetic oils with better heat tolerance and superior film strength. Brands like AmSoil V-Twin 20W50 or Mobil 1 Racing that cost twice as much as conventional oil but provide better protection under extreme conditions. They monitor operating temperatures obsessively using aftermarket gauges, since many Harley models don't provide a numerical temperature readout, just an idiot light that only illuminates when the engine is already dangerously hot. They've learned to recognize the symptoms of sumping, that sluggish, unresponsive feeling when the throttle doesn't produce the expected acceleration, and when it happens, they'll pull over immediately, shut the bike down, and let it sit for 20 or 30 minutes to allow accumulated oil to drain back to the tank before restarting and continuing their ride. These are dedicated riders who genuinely love their Harleys and are willing to put in extraordinary extra effort to keep them running. But these are workarounds, not solutions. These are compromises that shouldn't be necessary on a modern motorcycle that costs more than many new cars, and they're preventive measures that reveal a fundamental breakdown in the relationship between manufacturer and customer, where the burden of reliability has shifted from the factory to the owner. Let's talk honestly about the financial reality of owning a Milwaukee-Eight 117 in 2026, because this is where the rubber meets the road for most riders. A new 117-equipped bike, whether it's a CVO Road Glide with its massive fairing and touring amenities, a CVO Street Glide with aggressive styling and premium paint, a CVO Limited with every luxury feature Harley offers, or one of the new Softail models with the 117 engine, starts north of $25,000 for the base touring models. CVO models with the 117 easily push $40,000 to $50,000 when you include factory options, premium paint schemes, accessory packages, and the inevitable dealer fees and charges. That's serious money by any measure. That's new car money. That's down payment on a house money in many markets across America. That's college tuition for a year. That's a significant financial commitment that most people have to save for, finance over years, or sacrifice other purchases to afford. For that level of investment, buyers reasonably expect reliability, performance, and a motorcycle that doesn't require constant monitoring and maintenance beyond normal service intervals that are clearly spelled out in the owner's manual. But the reality of 117 ownership, the lived experience reported by countless riders across every platform where motorcycle owners gather, is dramatically different from the glossy marketing promises. Add in upgraded oil pumps at $2,500 installed to fix the sumping problem that shouldn't exist. Add frequent oil changes at $150 to $200 each if you're paying a shop to do them, which over 3 years of 2,500-mile service intervals adds up to thousands of dollars more than the factory service schedule would cost. Add premium synthetic oil for constant top-offs between services at $10 to $15 per quart, and remember you're buying 10 or more quarts per year beyond your oil changes if you're experiencing typical oil consumption. Add potential gasket repairs to fix leaks that develop as a direct result of oil system stress and overheating, repairs that can run $500 to $1,000 depending on which gaskets need replacing and how much labor is involved in accessing them. Add dealership diagnostic time when warning lights appear or mysterious power losses occur at $100 to $150 per hour, just to hook up the computer and read codes that often don't provide any useful information or point to any fixable problem. Over the first 3 years and 30,000 miles of ownership, which is a realistic time frame for an active rider, you're easily adding $3,000 to $5,000 in maintenance costs, directly attributable to the oil consumption and sumping issues that stem from the Milwaukee-Eight platform's fundamental design compromises and engineering shortcuts. That's not the Harley dream that gets sold in dealerships with their glossy brochures showing happy riders on perfect roads under blue skies. That's not the freedom and adventure narrative that Harley has built their marketing around for decades. That's a mechanical headache wrapped in chrome and sold at a premium price, and it's a bitter pill to swallow for riders who saved for years to afford their dream bike, who made sacrifices and delayed other purchases and set aside money month after month, only to discover that the dream comes with a maintenance manual thicker than the owner's manual and a to-do list that never ends. It's devastating for the retired rider who bought a CVO as their forever bike, the machine they'd ride through their golden years, only to find themselves spending more time checking oil and visiting the dealership than actually riding and enjoying the freedom that was promised. It's frustrating for the mid-career professional who finally achieved the financial stability to afford a premium motorcycle, only to discover that premium doesn't mean reliable and expensive doesn't mean problem-free. As we roll deeper into 2026 and look toward 2027 and beyond, the Milwaukee-Eight 117 remains Harley-Davidson's flagship performance engine. It's the power plant in their most expensive, most premium, most heavily marketed models. It's the engine that's supposed to represent the pinnacle of American V-twin engineering, the culmination of over a century of experience building big twins. But the cracks are showing wider with every passing year, and the internet has made it impossible for Harley to hide behind dealer networks and warranty fine print. Harley has made running changes throughout the Milwaukee-Eight production run in response to complaints and warranty claims. They updated the oil pump design after 2019 when the problem became too obvious to ignore. They revised gaskets and seals multiple times as leaks became epidemic. They've tweaked the electronic calibration to better manage heat and oil pressure warnings, trying to prevent the embarrassing scenario of bikes throwing warning lights and shutting down in front of shocked customers. But they haven't issued a full recall or announced a comprehensive redesign that addresses the root causes of oil consumption and sumping. There's been no press release acknowledging the problem, no extended warranty program for affected owners, no retrofit program to install upgraded pumps at no cost, no accountability for shipping engines that don't meet reasonable standards for oil consumption. That means 2024, 2025, and 2026 models may still carry the genetic defects of earlier versions, just with slightly better band-aids applied at the factory before the bikes roll out the door. The fundamental architecture remains the same. The oil pump is marginally better, but still inadequate under hard use or hot conditions. The crankcase ventilation is improved, but not enough to prevent all sumping under all conditions. The gaskets are upgraded, but still prone to leaking under the thermal stress and pressure fluctuations caused by inadequate oil scavenging. And most concerning, Harley shows no indication that they understand or acknowledge the depth of the problem, or that they're willing to invest in the comprehensive redesign that would actually fix these issues rather than just managing them at the margins. And here's the bigger picture that matters beyond just one engine or one model year, the context that every potential Harley buyer needs to understand. Harley-Davidson is facing existential pressure from multiple directions, threats that challenge not just their market position, but their very survival as an independent motorcycle manufacturer. Electric motorcycle competitors like Livewire, which ironically was spun off from Harley's own electric division, Zero Motorcycles with their increasingly sophisticated and capable models, and even new startups with fresh ideas and modern engineering are capturing attention and market share among younger riders who don't have the same emotional attachment to the sound and feel and tradition of a V-twin. Indian Motorcycle, Harley's primary American competitor owned by Polaris Industries, has been steadily gaining ground with more reliable platforms like their Power Plus engine, more aggressive styling that appeals to younger demographics, and better quality control that results in fewer complaints and warranty claims. Japanese manufacturers continue to dominate across every measurable metric of performance, reliability, technology integration, and value for money. Harley's customer base is aging relentlessly, with the average Harley owner now well over 50 years old, and the company is struggling mightily to attract younger riders who have different expectations about quality, who research purchases exhaustively online before visiting dealers, who share experiences and warn each other about problematic models, and who won't accept "that's just how Harleys are" as an excuse for engineering failures. In this challenging environment, Harley needed the Milwaukee-Eight platform to be an absolute home run. They needed it to be powerful enough to satisfy performance enthusiasts, efficient enough to meet increasingly strict emissions regulations, reliable enough to rebuild customer trust that was damaged by twin cam problems, and competitive enough to stand against the best engines from Indian and the Japanese manufacturers. Instead, they delivered an engine that's powerful when it's running right, but plagued with fundamental issues that undermine customer confidence and create a constant stream of complaints on social media, forum discussions, negative YouTube videos, and review sites that potential buyers read during their research. The 117 was supposed to be Harley's definitive performance statement, their answer to riders who wanted more power without going to the aftermarket or building a custom engine from Screamin' Eagle components. Instead, it's rapidly becoming a cautionary tale about the dangers of scaling up displacement without solving fundamental engineering problems. A lesson in what happens when marketing demands for bigger numbers and more powerful specifications override engineering caution about platform limitations and design constraints. It's an example of what happens when a company prioritizes short-term sales and marketing headlines over long-term reliability and customer satisfaction. Riders who bought into the 117 dream with their hard-earned money, their savings, their financial resources, are now faced with difficult and frustrating choices. They can keep dumping money into fixes and workarounds, treating their expensive premium motorcycle like a project bike that always needs attention, always requires monitoring, always demands the next upgrade or modification. They can trade it in and take a significant financial loss because the used motorcycle market is becoming increasingly aware of these issues through online research and information sharing, and resale values are softening for Milwaukee-Eight models, especially higher mileage examples where problems are more likely to have manifested. Or they can live with the bike's quirks and issues, checking oil compulsively, avoiding long trips where reliable performance is critical for safety and enjoyment, and always wondering if this is the ride where something major fails and leaves them stranded far from home. None of these options represent the ownership experience that Harley advertised in their marketing materials, or the customers reasonably expected when they signed the purchase agreement and rode their new bike out of the dealership with excitement and anticipation. This isn't just about one engine platform or one model year, or even one manufacturer's engineering failures. This is fundamentally about trust between a manufacturer and its customers, the unspoken contract that when you spend tens of thousands of dollars on a product, that product will work as advertised and meet reasonable expectations for reliability and durability. Harley-Davidson built their reputation over more than a century, through 2 world wars and the Great Depression and countless economic cycles, on the promise of American craftsmanship, rugged durability, and the freedom of the open road. That reputation survived the AMF years when quality suffered. It survived the Evolution engine's early problems. It even survived some of the twin cam issues, although customer patience was wearing thin. But when that promise is broken repeatedly by engines that consume oil, at rates that would be unacceptable in the 1980s, much less in 2026, when bikes are left stranded by mysterious power losses that dealers can't diagnose despite expensive computer systems and factory training, when riders have to choose between expensive aftermarket fixes or living with chronic problems that affect both safety and enjoyment, the trust erodes rapidly and may never fully recover. And once trust is lost in the motorcycle industry, it's incredibly difficult and expensive to rebuild. Riders talk to each other constantly at bike nights, rallies, and online forums. They share experiences honestly, both good and bad. They warn friends and family members away from problematic models and manufacturers. And they vote with their wallets, choosing competitors who deliver the reliability that Harley used to be known for, but seems to have lost in their pursuit of bigger displacement numbers, higher horsepower specifications, and flashier marketing campaigns that promise more than the engineering can deliver. The Milwaukee-Eight 117 could have been truly great, a legendary engine that defined a generation of Harley performance. It should have been great based on the specifications and the potential inherent in the design. On paper, it absolutely is great, with impressive torque numbers across a wide RPM range, strong horsepower that competes well against similarly sized engines, and that signature Harley sound and feel that stirs emotions in ways that Rational specifications never can. But engineering isn't done on paper in climate-controlled offices. It's proven on the road, in real-world conditions that include summer heat and winter cold, traffic jams and highway cruising, light loads and heavy touring with passenger and luggage, over thousands and tens of thousands and eventually hundreds of thousands of miles. And in the real world, under real conditions, ridden by real people who have jobs and families and lives beyond maintaining their motorcycles, the 117 is revealing itself to be a flawed execution of a fundamentally good idea. It's an engine that was pushed to market before the critical issues of its platform were fully resolved, before adequate testing under real-world conditions revealed the problems, or possibly after testing revealed the problems, but marketing and financial pressures demanded that it be released anyway. And now, riders are paying the price in money, in frustration, in anxiety about reliability, and in lost confidence in a brand they once trusted without question. The Milwaukee-Eight 117 was supposed to be Harley-Davidson's definitive answer to the demand for more power, more performance, more of everything that makes riding a big American V-twin special and different from the clinical precision of Japanese motorcycles or the boutique exclusivity of European brands. Instead, it became a harsh and expensive lesson in the dangers of bigger is better thinking without the engineering integrity, careful development, and quality control to back it up. Oil consumption that forces riders to carry extra bottles like they're riding a two-stroke dirt bike from the 1970s. Sumping that robs power and creates dangerous heat, turning a premium touring motorcycle into a sluggish disappointment that can't maintain highway speeds on mountain grades. Random power losses and warning lights that leave riders stranded on the side of the road, wondering if they'll make it home. These aren't minor quirks or acceptable compromises that come with owning any motorcycle. They're design flaws inherited from a platform that needed fundamental rethinking from the ground up, not just resizing with a bigger bore and longer stroke to achieve magic marketing numbers. So here's the critical question that matters for anyone considering a Milwaukee-Eight 117 in 2026 or beyond. Whether you're shopping for a new CVO or looking at used models that have depreciated into affordability, would you buy a 117 knowing everything you know now after reading this? Would you drop $25,000, $30,000, $40,000 on a motorcycle that has well-documented issues, requiring thousands more in upgrades just to achieve the reliability that should have been engineered in at the factory? Would you accept checking your oil at every gas stop as a normal part of motorcycle ownership? Would you trust your safety and your investment to an engine platform that has documented, verified, repeatedly reported issues? Going back nearly a decade with no comprehensive factory fix, no recall, no extended warranty, no acknowledgement that anything is wrong? Or would you step back, take a hard look at the alternatives from Indian and the Japanese manufacturers, and put your money into a smaller engine that might make a few less horsepower and a little less torque, but also won't leave you stranded, won't burn through oil like a poorly maintained lawnmower, won't require constant vigilance and anxiety about whether this ride will be the one where something catastrophic fails? Drop your answer in the comment section below. Tell us honestly if you own a 117 and what your real-world experience has been over however many miles you've put on it. Tell us if you're shopping for a new Harley and whether this information changes your decision or makes you reconsider what model to buy. And if you know someone who's considering buying a Milwaukee-Eight 117, someone who's dreaming of that CVO Road Glide or that Softail Lowrider S, someone who's saved up money and is about to walk into a dealership, do them a huge favor and send them this video before they sign the papers and ride off into what might turn into a very expensive and frustrating sunset. If this video opened your eyes to the reality behind the marketing and the truth that dealerships won't tell you during the sales process, hit that like button and subscribe to this channel. We're committed to bringing more brutal truths about the motorcycle industry. More stories that manufacturers don't want you to hear. More information that can save you from expensive mistakes and bad decisions. More real talk coming soon about other models, other manufacturers, other issues that affect riders, but don't get discussed honestly in traditional motorcycle media that depends on manufacturer advertising dollars.